that was posted yesterday in the GitHub. We're going to start off. Sorry, I've lost track of it real quick. Thank you. Okay, got too many tabs open. All right. So we had an internal commitment to ship the specs for DevNet 0 on the 31st, which was Monday. Just curious if maybe or Gajinder, if one of you could kick us off by giving us an update on the status of that. Or
I
really
guess I can.
anyone.
Yeah, I can start. So for Ream, I think. Um, so we're just waiting for the specs for the transition functions. That Gaijinder just mentioned in the Telegram group. So we have to review those. And then get them merged into the repo, and then trigger that into our code base. Um, so I think that's like the main remaining part. Then there are like some other small features that we are developing, but it's not really a blocker for DevNet 0. For example, like we are building like persistent, so basically DB on top of our client, generating like the SecP keys, stuff like that. So I guess like for us, in order to get DevNet 0 ready, so right, get the remaining specs merged as soon as possible, and hopefully like we could trickle those down into our code base in um, let's say like 3 to 5 days from when it's merged. But on the other hand, the other update I can give is in terms of Ream itself, regardless of the specs, we were able to run the 3SF under a local 4 node environment for a few hundred slots. So that seems fine. So it's only a matter of like refactoring our code to align with the specs that's being submitted.
Great. Guillaume or someone from the Zeem team, are one of you able to provide an update?
Um, yeah, I should be. Can you guys hear me?
Yep.
Okay. I don't know where Gajinder is. Yeah. I don't have the full picture, but I can definitely provide some of a part of an update. So we merged the metrics things the last like yesterday, I think. Yeah, I've been busy integrating some PR, so we're getting ready. Um, Regarding the what's that called, the testnet, so itself, like the kurtosis configuration and the config from sorry, not the config, the Genesis generator. I am waiting to hear back from PK. So I hope I'm going to hear from him soon. But I think we're more or less good to go. We just have to do the to give it a trial. So we're building the images. All we need to do is to have the kurtosis configuration to check everything works. If something fails, we're going to start debugging. So yeah, okay. Ideally, that will be done in a couple hours. We'll see, but it shouldn't be too complicated given the simplicity of the Genesis. Um, Regarding the Grafana stuff, I haven't done that yet, but I'm going. That was in my plan to do it today. I was a bit held back by some debugging, but yeah, I will do it today, and we can also make some progress on that. There's probably a ton of other things, but it doesn't come to mind just now. So yeah, that's it for the update so far.
Sorry, I was muted. Katja.
Yeah, hello everyone. Question to Guillaume. Do you mean any specific metrics by this PR? or maybe just in general?
No,
library?
it's not related to. No, it's just about the ability to export
Mhm.
metrics. So we're not specifying any metrics yet. It's really just the ability to post them somewhere so that they can be loaded into Grafana, so that we can do some basic debugging during the post-quantum testnet launch. So nothing, nothing as advanced or as organized as what you're doing. It's just a capability.
Yes, thank you. Got it. But that's great anyway. Thanks.
And then, you had in the chat, I think, also something related to metrics. Maybe, I don't know if there's anything you want to say, but you were also thinking for a moment that you needed to have specific metrics in mind.
Yeah, so it's basically what Guillaume said.
Okay.
Both I think like both Reem and Seam are able to export the metrics now. It's just a matter of like defining where exactly do we want to measure and make sure like we are measuring like the exact right same moment. So we have metrics that are usable across clients.
Okay, great.
I think that yeah, so I think that would be best after we merge the remaining specs for the fork choice. Because I guess like most of the measurements that we want to do for DevNet 0 at least is probably somewhere around those consensus and fork choice.
Yeah, and
And then-
having kurtosis would be great as well.
Can you elaborate a bit having kurtosis metrics?
I mean,
or
no, just running the clients on kurtosis. If I got it correct, it's not possible now, right?
I think Guillaume is working on that, right?
So I'm not sure I understand the question. Like, yes, it's possible to get metrics on kurtosis. They have containers to collect them. But
I mean, just
yeah,
in general, running on kurtosis, is it possible already?
yes. Sorry, to run the DevNet on kurtosis? No, it's not possible. That was what I tried to convey during my update. This is something that I need to work on with PK, but I'm gonna do it this week and see how far we get.
Okay, great. Thank you.
Do I understand correctly that, but eventually for like to complete DevNet 0, we'll still need to run that on kurtosis?
Most likely, yes. I mean, if we're going to get any support from the ETH Ops, this is their favorite tool. Okay, maybe favorite is a strong word, but this is the tool they inherited. So they've been maintaining it, and all their infrastructure is done from this tool. I personally hate it, but that's because it's very good for running an environment that is quite stable. When you are doing debugging, it's really difficult. But I have some updates to it that I hope I can get them to merge. So yeah, it's not gonna be it's not gonna be available for this DevNet, unfortunately. But yes, so as a result, expect that we will be running kurtosis configurations, and I mean ETH Ops presumably will be running those kurtosis configurations, and we just provide them with Docker images. And this is what kurtosis does. It downloads the images, runs the clients, initialize the Genesis block and all the Genesis configuration for everybody, and then supposedly that avoids the situation where everybody runs their node in their little corner and someone forgot one switch and another one. So it's supposed to save time, and according to them, it saves a lot of time when you're deploying test nets and things like this. So, like I said, for development, it's horrible, but when it comes to actually running a test net, it's a very good tool.
Great. So I guess before we move on, was there anything that I don't know, from either the Ream or Seam side or the Quadrivium regarding updates to the spec for DevNet 1? I know that was sort of like the fast follow. Both things were being done in parallel.
Yeah, I've joined in. So yeah, I would like to add that I think specs for DevNet 0 are mostly there. So me, O, and June, we had a conversation following up on the fork choice as well. And yeah, so it was, I mean, a whole lot of it was simple translation from what Vitalik has done in his 3SF mini P2P and sticker code. And so we just need to clean it up, and I think we are good to go on that. And we should be able to translate it to our clients easily as well.
Excellent. Good to see you, Gadgeter. So I know that tomorrow we were going to try to do a walkthrough of whatever we can with the multi-sig spec. Before we jump to that, Mercy, I saw your comment that you wanted to talk through this PR that I'm dropping in the chat right now regarding the hash sig. Could you maybe tee that up and let people know what you're looking for feedback on?
Yeah, so there's a concern of merging it to the hash sync or using it as a separate tool. So that is what I need to know. Are we going to use this? Because on the last call, Gijenda did mention that we still need it on the hash sync repo. So I don't know if Benedict is here, if he will be the one to show more light on how this is going to go down.
I think that right now Benedict is on holidays. I think he will come back soon, and once he come back, I will discuss that with him to check. I have the problem in mind, and yeah, I definitely need to check with him if we will include that into the repo or not.
Excellent. Great. Then Thomas, while we've got you, is there anything that you can do to kind of help us walk through and learn a bit more about this multi-sig spec?
Yeah, I can do that. Maybe Guillaume, you had a question before, like you raised your hand, so.
Yeah, I had a hopefully quick question. So that tool that Mercy is working on, do we need it for the testnet? Because my understanding is that it's going to be round robin, so we don't really need any validators. So yeah, my understanding is that we don't need it for this testnet, and we can take our time. Like there's no rush. Is this the correct assessment?
Yes, we don't need it for DevNet 0, but even in DevNet 1, the proposals will be round robin, just that now the validators will sign it. In DevNet 0, there is no signing of proposal or votes. So that's that.
Yep, exactly. So yeah, let me go through the code base. I will share my screen so that we can all see together. So can you see my screen?
Yep, perfect.
Perfect. So what I did, so basically my work was about like migrating the spec to Python file. So basically, if we open like the spec repo, here we have some docs from the client where we have markdown file. This is what was presented last week by Gajinder, and another file that will be merged, but this was a goal there. So my work is in the source folder. Here we have the lean spec folder, and inside we have some subspec. So we have different folders there that contains each of them different type of subspecs. Also, we have a type folder that contains very basic types, such as, I will just show you one, for example, just uin64. Maybe at some point we will like just import an existing type of another Ethereum library, but this is not a problem. This is just a very minor change. So for now, we just defined a very simple type. And so you have other types for that. So for example, like the output of a hash function or any small types defined in this folder, so we can add any type we want there as we go. This is just like a separate folder. The only constraint there, maybe just after I will move to the main spec, is just to have like very typed structure so that we don't have any possible confusion. Always put some types in the stuff we define. In the subspec, I have different folders. So I have a chain folder where I define some very basic devnet config constants. So just all of the constants are there. For example, just to cite one, the slot duration and anything. So you have all of the config there. Then I have a folder containing all of the containers. So for example, we have a block file in there, and we have specific class for specific objects, for example, a block body or a block header or simply a block. And so we can just reuse these basic objects all around the code. For at the moment, they are very simple because we based everything on the simplest possible things. This is always linked to some docs that we have in the markdown files. So this is always very simple, very lean, containing only the minimal info that we want, and we can update these classes as we go. So we have one file per point. For example, we have one block file, one checkpoint file, one config file, and one state file to contain everything that we need. So that is about the container. If we speak about, then we have also the networking. So again, some constants, some gossip sub stuff, and some messaging stuff. So at the moment, these are just all the basic defines. We can update, remove, modify anything that we want, but this contains, like, let's say, basic config for the networking layer. That is all about the generic stuff. But now if we talk about like the cryptographic layer, let us say, we have first defined like the koala bear, that is our prime field. So for those who are not aware of, a prime field is this is a prime that will dictate how we operate over our finite field. So this is a prime number, this one. And we define his name is koala bear, and then we define the finite field operation over this prime field. So just basic operation like addition, subtraction, points negation, multiplication, pause, so that we can use any element of this class with just a plus to define the addition. This all of this function overwrites the different operators so that this is very easy to use. Just to show you there also, we have a test folder at the root of the repo where we have also tests for all of the subspecs. So if we take, for example, the koala bear subspec right here, we have tests for the field. And if we open this test about the field, we have very basic tests. For example, we just test addition, we test subtraction, we test point negation, we test multiplication, all of this with very basic numbers. So that, for example, we check that a multiplication is equal to an expected values and anything. So very basic tests just to check that everything is okay. So after defining all of these basics, finally, we just have the finite field defined. And what is very nice in there is that if at some point we want to change the prime field, we just have to change the prime there and the 2 or 3 constants that are there, but the rest of the class remains the same because this will always be the same. Of course, like the implementation there are not defined in an optimized way. This is just defined like to satisfy the needs that we need in the simplest possible way, but this is not optimized so that if you look at Plonky's free version, this will be obviously completely different and a much longer implementation. Then if we go to the Poseidon there, you have the Poseidon implementation that is more complex than Koala Bear, so we will not look into the very EV details of this one, but basically this contains some constants that are there generated by Sage script from the paper, and it also contains the main file that is the permutation file. And so basically the function that we expose to the user is just this one, the permutation. This is what the function, this is the function that the user will use when using Poseidon. Inside this function, we have a call to all the other functions of the file to generate this permutation, but the user will only interfere with the permute function, nothing else. A user shouldn't call any other function of this file. And so inside this permutation, we just call the round constant, in fact, we can decouple that into different steps. That we have a first step there that is an initial layer of the hash, then some full round, then some partial round, and finally some other full round. So this is basically the decoupling of the function, and there you have each time some utils. If you want to go deeper into the function, I tried to put EV comment on each line so that the user is aware of what we are doing each time and can follow the steps line by line. But roughly, the step is processed by layer, and so you have an initial layer, another one, and a final one. This is the step of the function, and at the end, you just return the final state and your permutation is done. And this is what the user will want to call. And so the same, if you look at the testing file there, I just put a test on the permutation. So how I generated this test, I just took random inputs and I computed the expected outputs using Plonky 3 library, which is already audited and performing already in production. And so I just compare my Python implementation with the Plonky 3 implementation to be sure that I obtain exactly the same results. The same for the two widths of the permutation, 16 and 24. That is my Poseidon implementation. And finally, let us say the most complicated one, so I will not go into the detail there also, but the XMSS signature. So basically, it mimics exactly the Rust implementation. So you shouldn't find anything new because these are the same tests, the same functions, the same implementation, the same interface as the Rust implementation. And just as a note, we don't want any client teams to develop this primitive themselves because we just provide them the code and we just want them to use the code. So this is not needed for you to re-implement that for security reasons, because we think that this is quite complex to have every single detail perfect. And we prefer for now clients relying on like a common futurely audited library. I will just present you this file. That is the interface file. And in this interface file, you have like the main interface the user will use. So in the header of the file there, I put like the specification high-level function, which are keygen, sign, and verify. These are the three functions the users should use to generate the key, to sign a new message, and to verify a signature. And so the three functions are provided inside this XMSS class. So you basically initialize the class with a couple of parameters that comes from the other file. Then you generate your key. You generate your key through different steps. As you can see, you have an activation epoch because no matter what your lifetime is, you can generate a smaller activation time. And so you can choose to have, for example, a big lifetime, but a smaller activation time. This is what these arguments are about. And you just basically generate your key. So you go through the procedure, generating some random parameters, generating some Merkle tree to build your XMSS stuff. This is like the theory of XMSS, and I will not go into the details, like to avoid overloading my talk. But at the end, the goal is to generate this. These are the public key and the secret key. This is the final output of the key generation. So in the public key, you have, for example, the roots of the Merkle tree and some parameters. And in the secret key, you have a bunch of parameters. So you have the tree, you have some PRF key, you have some parameters, you have your activation epoch and the number of active epochs that you chose. Now that you have this, you are able to sign a new message. So as you can see, the secret key should be one of the parameters, as well as the epoch, as well as the message that you want to sign. So through the sign function, you can sign any new message. Again, this goes through a procedure. Be careful there. I put a warning that should be also in the Rust implementation from Benedict. A secret key for a given epoch must never be used to sign two different messages. And again, we go through another procedure that you can study, but at the end, the important stuff is that you generate a signature. This signature contains the path that will then be used to verify your signature, some hashes, and a randomness row. And finally, the final function, the most important one to spec, because the verify function is the one that we will use into the aggregation of signature. So via this function, you can verify the message. So via the public key, via the epoch, via the message, and the signature that was generated there, you can just verify the message. And so
if you could pause real quick, Gadninder had a question. Gadninder, was this specific to a section that was just covered, or?
Yes. So basically, when you mentioned about the API of key generation, which is basically there is activation epoch, and there is lifetime, and then there is how many epochs it is to be active, right? So in this activation epoch for us would be 0.
Yep. Correct.
Or max active epochs is the lifetime, I mean. But
the activation epoch is the starting epoch for which the key will be valid. And the num active epoch is the number of consecutive epochs the key will be used for. So I think that in the constant we define for the devnet, there is a lifetime of 2 to the power 32. And you can define a smaller activation range for the key generation to be faster.
yeah, that's the clarification I wanted. Thank you.
Yeah. And so you have the sign, and you have finally the verify. And so the verify function is able to verify the signature of any message. And at the end, it just output a Boolean. And it will just verify the path and check that the routes that it obtained by rehashing everything is just the expected route. If I just show you this verify path function there, it is in the Merkle tree file. At the very end, what is important is that it means after iterating through the entire path of the Merkle tree, the final computed node should be the root of the tree. And if it is the case, it just output through, and the verification succeeds. So that is basically the interface. And then you have a bunch of files to do some different stuff. We can, of course, simplify these files. Some of these files are just here to make some randomness, so we can just simplify them or anything. But the important stuff to remind is the interface. Another important stuff about the constant is that here I have a constant file where I define some constant parameters about the signature scheme. and we can instantiate a new signature scheme by modifying this file. For the DevNet 0, we agreed on this parameter based on the benchmark done by Benedict on his implementation. This seems to be the best one we have for now. But the problem is that if you try to use that into the Python spec, this will be way too slow because the activation time is long, the Python implementation is not optimized, and Python is not optimized. So this will be really slow. The key generation will take a couple of minutes or hours. This is not good. So I just created another test configuration where the parameters are not intended for production use case, but are really, really small. And so we can just conduct our test and run our test suite in a reasonable amount of time. Yeah. And so this is finally it. At the moment, this is just the specs that I have, but we will iterate with time. And I think that my next step will be to implement the state transition function and everything around 3SF, basically. So yeah, that is basically it. And also, I will probably do a more extensive presentation of this during the Lean consensus call on Friday.
Yeah, just to echo what Kamal said in the chat, can we also sort of in the constant put what exactly is the signature size in bytes, as well as what exactly will be the root of Merkle-Tree in bytes if it's not 32 bytes and is different because we are using a different hasher?
I think that this can be configured into the constant. This is something that we can change, but I am not exactly sure because this is a constant that we have from the beginning inside the Rust implementation. So I am not exactly sure about the consequences if we modify this constant.
No, not asking to modify the constants, but for example, if we have that, okay, signature size equal to these many bytes. So it's basically for the reference very clear to the eye that, okay, this is what we need to create the type for. And similarly, what is the public key size in bytes?
Yeah, exactly. Yeah. The public key and all of these parameters are constrained by the constants that we chose in the stuff. Yeah.
Yeah, can we just put the final calculation out there so that, we don't have to
Yep.
drive it in our own way? That is.
Yeah, we can put. So you mean having the signature size calculated directly into the Python spec as a function of the parameters we have, right?
No, even for just say const signature size is equal to this and const public key size is equal to this.
Yeah. Okay.
Maybe just have a comment there with signature size.
I think I just saw your comment. I think it's what Ho just mentioned is 3,000 bytes for the production config, for the constant that we chose in the production config. The test config is not relevant at all because this is just to run some tests, so this is not relevant at all. But for the production config that we chose for the DevNet, this is the size, yeah.
Thomas, fantastic presentation, really great stuff. Earlier, there was a question from Giacomo in the chat. I don't know if you saw this. Do we perform domain separation in the XMSS signatures? Is this part of the spec?
Yep, this is part of the spec and we perform domain separation. I can link you to the specific part of the spec about this, yeah. Yeah, I will send you the link afterwards, but yeah, we do some domain separation.
Great. Any other questions on
Knowing
Toma's
also that
presentation.
I have heard by, this is another topic, but I have heard by Emil and Justin that the encoding that we have right now at the top of the hypercube, that was the last work of Benedict and Dimitri, was maybe not the most optimal one for recursive aggregation in the minimal ZKVM. So maybe this will change in the future, but this is just a parenthesis. Don't know if you, Justin, want to add something about that, but for the moment in the spec, I just put the hypercube stuff because this is the latest config that we had, and let us say the most performant one, but this may change in the future.
Yeah, so just to provide a little bit of context, there's two parts to the Winternet verifier. There's the verification of the chains, and this is just like very simple hashing, and that determines how much hashing is involved and also how big your signatures are. And then there's this other thing which is called the encoding, which basically takes the message that you're trying to sign and encodes it into a point on those chains, what we call a point in the hypercube. And what we've done so far in the papers is that we've assumed that the encoding is free, and we only look to optimize the signature size and the amount of hashing. But actually, in practice, the encoding is not free and it needs to be snarkified. And right now, as it's defined, it's not snark friendly. And so one of the things that we're looking to do in the workshop in Cambridge in October is try and co-design an encoding which is maximally friendly to the ZKVM that we're developing. So on the one hand, we have Emil, who has this new ISA, which we call lean ISA, which has 4 opcodes and 4 precompiles. And on the other hand, we have Benedict and Dimitri and Michal that are experts in encodings. And if we get all of these people in the same room, then hopefully we can have a good outcome.
Excellent. I guess that was the last item on the agenda. I don't know, Gajinder, Guillaume, June, I see some activity on the project board. Is there anything that we wanted to go through on the project board with open tasks? Anything, any blockers at this particular time? Ladislas.
Yeah, so before we get there, I have a quick clarifying question for Thomas, or I guess for the group. And Gajinder hinted at this already. I'm just curious, do we have I guess benchmarks or a bit of an intuition, like how activation time, like shortened activation time for the key generation sort of relates to the lifetime? I think we will, as my understanding is that we'll only need this in DevNet 1, but so like how, I guess the concrete question would be like, how do we have to set, or should we think about activation time with a constant lifetime of the key?
I think that maybe I have seen like Dimitri in this call, so maybe he will better answer than me about this question. But my point there is that at the end, like the key generation algorithm could be long. For example, if we assume like 2 to the power 32 lifetime, the running the key generation could take 1 to 2 hours, I think, using the Rust implementation. And so for that, if we want to use that, we will use that in DevNet 0 and DevNet 1. We can just say that we will use this lifetime, but we want our validators to have like a much restricted activation time, so that we can just put into the input of the function smaller activation time, so that it will reduce drastically the key generation, and we don't need 2 to the power 32, at least for DevNet. And I think that this is also currently under investigation if we will have this also needed for the final mainnet, because maybe we will give the opportunity to new validators to enter without having to do like the full key generation if they want to opt in for a smaller activation time, for example. This is the point of having that, I think.
Well, what is definitely possible is to have this lifetime sort of dynamic, so that the validator may start with a shorter time, like show a smaller tree, like to the 20 or something, but then the tree can grow. Well, the public key may change, but at least for the beginning, we don't have to spend that much time to activate. We can start with 2020, and then by increasing the tree size, we can go up to 2032 incrementally. We just have to update the public key on the fly.
So that would be some sort of an epoch processing where you will say that, okay, you know, and every epoch I will enroll the new update for the key. But I mean, maybe we could move to that sort of a scenario, but in that sense, basically the clients will have to continually generate the key for the next epoch as well.
So there are complications if we allow for key rotation. For example, slashing becomes significantly more complicated because you might need to slash someone on a already rotated key. So I think the suggestion that I prefer is to have a very long maximum lifetime of 2 to the 32, and that has a minimal impact on the signature size. And if you want to generate fewer keys, then you just generate fewer keys, and then everything stays fixed size across all of the dev nets and also across mainnet. And you don't have any key rotation logic, which doesn't complicate the slashing.
And apart from this, Justin, what do we think that for different kind of signatures, we will enroll different keys into the validator, or what kind of scheme do we think, for example, for attestation and proposal?
So my thinking is that there's basically one pub key per validator, and it's fixed for the lifetime of the validator. And for are you asking about the complications with the proposing and the attesting? I mean, there's various solutions here. Like one is in the slot where you're a proposer, you just don't test, and your proposal is includes the attestation implicitly. And then another way to do it is to basically split the keys into two groups: the proposer keys and the attester keys. And then the main trade-off here is that you basically have to spend twice the time to do the key gen. But yeah, the first proposal seemed to work fine.
Just one quick question, follow-up question. So what do you mean that proposer can include the vote implicitly in the block when he proposed? So I just want to be more clarified about your first suggestion.
Right. So we have a container for the motion of a vote, which has the source and the target and whatever other things. And that object can literally be part of the block that's being proposed. And so the main kind of thing that's a little bit exceptional is that this particular vote is not going to get aggregated with all of the other votes because the message that's being signed is different. But otherwise, it's just mixed in with the other votes kind of as part of the state transition function.
Right, but if, for example, I mean, this might just work for proposer and attestation coupling, but it might not work for other key types where we might have to then enroll them into the validator, I guess.
Sorry, it wouldn't work for what?
So for example, for signing slashing messages or so, I mean, if, for example, some node wants to submit some slashing, or I think in that they are signed right.
So in a slashing message, my understanding is that you have previously signed attestations from other validators, like you as the entity, putting slashable messages on chain. You just have to sign your block that contains the slashable messages. I mean, right now we do have RANDAO, which uses signatures, but there's a way to do RANDAO with just commit reveal that doesn't rely on signatures.
Yeah, basically
And
we
the
don't
other
whistleblower, so I'm thinking that a whistleblower might be signing so that they will get the rewards, but right now we don't have whistleblower rewards, I think.
So the problem with whistleblower rewards is if it's an entity other than the proposer receiving the reward, is that the proposer can just steal the reward for themselves. They could just look inside what's being whistleblown and just copy paste and sign it. If I recall correctly, on the Beacon chain today, maybe I'm wrong, but there is no signature for whistleblowing. You just provide on chain the slashable messages, and then there is indeed a reward for the current proposer, but it's not a reward for someone else. And here again, like the proposer signature will handle that. I mean, one thing we have today is the sync committee, but that will go away. So as far as I can tell, the only two places where we need to do signatures are proposals and attestations. And for proposals, we just handle this as a special case where you don't attest directly, you just attest indirectly through your proposal.
Great. Camille, did you want to share your screen and do a quick update on the PQ aggregation simulation work that you've been in?
Yeah, sure. I can do it really quick. I already once went through this report, but it's been a long time ago, and since then, actually, yeah, we performed a lot of more simulations. Basically, we were not really satisfied with some results. Like, well, we noticed that if we use our standard assumptions like EAP 7870 restrictions like 50 megabits per second per node, and we use standard COSIP sub, we basically can aggregate in around 3.9 seconds, which is not acceptable considering targeting 4-second slots. So ideally would be maybe having something around 2 seconds so that we have some time for block propagation and global snark propagation once it is aggregated. So yeah, we conducted more experiments. So yeah, I'll repeat about topologies. Oh yeah, maybe I'll add that, yeah, we also, from the last time, we also added tests for so what we call aggregators only grid. This is basically grid topology, but the grid only is among the aggregating nodes, whereas non-aggregating nodes, the signatories, basically the signers, they send their signatures directly to grid aggregators. So that way, we basically don't need to expose the requirement for the all attesters to basically expose their public addresses, because well, for whoever participates in grid, we basically need to know their IP addresses, and this breaks some existing privacy assumptions. I have a small section about privacy discussions here after some discussions with Raul, Chaba, and others from P2P group. So yeah, there are still some privacy concerns. For example, aggregators that might actually learn the IP address of validators who signed the message. And we basically want to avoid this, but there are ways how to avoid this. So I provided some ideas, but yeah, it requires some additional investigations. Basically, yeah, also starts since last time we also tested gossip sub 1.2, basically gossip sub with I don't want messages. Really briefly, yeah, I can say that gossip sub 1.2 really doesn't give a lot of improvements because basically what it does is once some peer receives some signature and wants to advertise that it already has the signature and sends I don't want message. So basically everyone else is not sending this signature again. But usually the other duplicate signatures, they are already kind of in the wire. So the message was already sent. So basically duplicates already received. So yeah, we also tested this topology, as I said, with aggregators only grid, which is on graphic as a label, this grid signature half direct. Or that means basically, well, each signer sends to 4 random aggregators. It actually provided some worse results compared to classic grid, but that's because we kind of have one additional hop. But overall, yeah, it's still better than gossip sub. Yeah, there are also like plots for the number of duplicates for different topologies, if anyone's interested. And yeah, then for global aggregations, so for standard gossip topology, we basically, yeah, in this simulation, 100 megabits per second speed for nodes and using snark aggregation rate of 10 snarks per second. This is the rate that I asked Emil, who kind of what is the expected rate we might get. And using 1,000 signatures per second, aggregation rate for signatures. Yeah, we basically got these results. So basically, yeah, we need approximately 4 seconds to aggregate a lot. And that's for 8,000 validators split into 8 subnets. So each subnet has 1,024 validators, and among them, 10% are behaving like aggregators. And if we use grid, results a bit better, 3.2 seconds, but still that's a lot, I think. And then we started kind of exploring what we actually can do, what we can to reach our target basically in 2 seconds. First thing I think which we can test is yeah, aggregation only topology. This also gives well, just to check how this topology behaves. And here we're playing for grid 3.4 seconds. A bit worse, as I said, because of additional hop. But yeah, some other things that yeah we can expect is that, well, according to Nielsen law, we might expect that yeah, bandwidth limit growth kind of 50% per year. And if current requirement is 15 megabits per second, according to EIP 7870, we might expect like in 4 years, we maybe can put through bandwidth limit of 200 megabits. And if we do this, yeah, results got better. So with grid topology, we go below 3 seconds. And then if we actually increase our compute power from 10 snarks per second to 20 snarks per second, that's kind of optimistic assumption. But if we can do this, then yeah, basically with grid topology, aggregation could happen within 2.3 seconds. Yeah, that's kind of the results of our simulation. Some other things that we actually wanted to check that, but we just weren't capable is kind of, here we use TCP, but instead we could use QUIC. We actually integrated QUIC into our simulation, but the simulation time kind of increased exponentially. Yeah, we basically need to optimize a bit how Quick works. Maybe instead of doing this actual encryption, we can just replace it with some artificial sleep and do some other stuff. Maybe if we spend more time on this, we can test how Quick would improve situation. And so it definitely will improve, but I don't expect it will be like a drastic improvement. Also, we kind of tested a lot of different other ideas that actually didn't provide much improvements, like distributing signatures. Well, first hop kind of happens to with large fan out to many neighbors, and the next hops happens like using standard gossip sub, just to few neighbors that didn't help much. That actually created a lot of duplicates. Yeah, there are also some optimizations that we applied, like for global aggregators, it doesn't make sense, for example, to propagate snark from each group more than once. So if we, for example, already observed some snark from group 1, and then we receive another snark, assuming it kind of proves the same number of signatures, it doesn't make sense to propagate the second snark again, the second snark, I mean. So another optimization we can do is kind of, for example, early announcement of snark. So we kind of send bit field not when some aggregator created a snark, but actually when it started the aggregation process. And that way, global aggregator kind of can send their I want message. And once the snark is ready, local aggregator already knows who to send their snark. So ideas like that, we also checked in this report, and maybe there are other ideas. If you want us to check them, we're happy to implement them in our simulator and check if they provide any improvements. But that's that's kind of the final state of this report. I will share it to everyone. Feel free to comment or DM me if you have any questions.
Excellent. Thanks, Camille. Curious, have you shared that with some of the other networking people that are going to be in Cambridge with Giannis and Raul?
Yes, Raul went through this. I don't remember if Giannis was in the groups where I sent and discussed that. Probably he was there. But anyway, maybe I will send to Interop group and send to the group.
Very cool. It'll be interesting to see what type of performance we are hitting at the conclusion of that workshop versus now. Great. Were there any, I guess, final items, anyone blocked on anything on the project board or related work? All right. No news is good news. That I think is it for this week. I'll hope to see all of you on Friday, as noted in the chat earlier and by Thomas. We've got Lean Consensus Call number 7. We're going to be doing an even deeper dive into the multi-sig spec. And I know that we're going to hear from Philippe and Emil and Justin. I might talk a little. Thomas, it's going to be a good time. All right.
Thanks, Will.
Thanks a lot.
Bye.
Bye, guys. Thank you.